Okay, so you need to get out the paper that you got on Thursday that has the big graphs of sine and cosine on it, which I did ask you to finish if you didn't do it. You need to get out page 5. Yours should be blank right now because there's nothing written on it, but page 5. And you're gonna need just a little bit of regular note paper. So this is page 5. It says page 5 on it. So this guy, the graphs of sine and cosine, and paper. Page 5. All the just page 5. Just page 5. Okay, so what we are going to be learning with this section 4.5 and 4.6, we're going to be talking about how do you graph sine, cosine with all of the transformations. So we're going to revisit transformations again. So I want you to take a look at the sine graph. Okay, so sine should look something like that if you did it correctly. So here's my question, whether you have it done or whether you don't. If you were going to make a decent sketch of a sine graph, how many points would you need? Okay? If you were going to make a decent graph of sine, just a sketch, doesn't have to be beautiful, how many points would you need?
5.
Did you say 16?
I counted them.
Sven? That's not a sketch. That's a graph.
5.
Melissa says 5.
4.
Well, let's go on 2, 4.
1. 5.
I think 6.
Just Jack's gonna draw a random dot. Did you just say 1?
Oh,
I didn't say it.
Who said 1?
3.
Was it Sven?
It was cold. Whoa.
It was not. Okay, I will tell you that I believe that's more than 3.
Or to get to 3. Make it look straight.
Okay, so if you said 3, what 3 would you say you would want to use? What x values? So the 0. Okay. What else? This one? Yeah or no?
No, the next one. 7.5. We get it.
This one?
Yeah. Why would you?
Okay, the question was, somebody said 3 points. So I'm asking, if it was 3, which 3 would you pick? Which 3 would you need?
I'll do the first point.
I heard a person say pi over 2. Okay? 3 pi over 2? I disagree with that, because if you need more, if you're going to be more accurate, if you're going to be accurate, you need more. You need the end. And Lawson, what else do you need? I'm asking you because I agree with your 5. That's fine.
To intersect.
You need this. Okay? You need 5. What are the significances of those 5 points? Maximums and minimums. And zeros are x-intercepts. Okay? If you have those, though, you are going to be able to make a perfectly fine sine graph. Okay, so what I want you to do on page 5, I have lots of pages here. On page 5, near the bottom, there's a table. Underneath the table, it says, there we go. You've got the graph of f of x equals sine x. So the first thing we're going to do is put one of these on here so it's your reference. I promise by the time we're done with this lesson, you won't even need the reference. But for now, when you graph sine, there's only 4 numbers that you really need to write down. We're going to go all the way out to 2 pi, which is what you had on your paper that you did. We number that guy because he's important. We number halfway. So what's halfway? 1 pi, correct? You don't have to have the 1. The in-betweens are also important, but I will not make you number them, and that you will appreciate that tomorrow or the next day. So we'll just mark those. They're important. We need them, but you don't have to number. Now, those two numbers there. Two numbers on the y-axis. What's the largest this gets up to? 1. What's the lowest it gets?
0. -1.
-1. Okay, so sign the 5 points that you need. Once you draw this, it's pretty easy, but the 5 points that you need, sign starts at the middle, goes to its maximum at that next point, goes back to the middle, goes to its minimum, and goes back to the middle. So sign middle up, middle, bottom, middle. Okay, when you graph these, you have to remember that it is curved. These are not half circles, okay? They're not half circles. They're also not parabolas, though. It's a different kind of graph. Okay, ooh, this went really good until that last bit there. Okay, they are not pointy. Okay, pointy graphs, I will take points off. Okay, these are really nice, smooth curves. Okay, now, take a look at your cosine graph that you have on your paper. How many points do you think you need to draw a decent sketch of a cosine graph?
3.
You're going 3.
5. Yeah.
I'm thinking 5. Okay? What 5?
Wait.
The same ones. Okay? Different things happen there, but it is the same 5 points on the graph of cosine. Okay, so on cosine, 2 pi 1 pi. Stop talking, please. So the same 5, but again, different things happen because it's cosine graph. However, we're still looking at maximums, minimums, and x-intercepts. Okay, if you can get that, you're going to have a pretty decent sketch. What's the maximum cosine gets to? 1. What's the minimum cosine gets to? -1. Okay, again, 4 numbers, super easy. The difference between sine and cosine is that cosine starts at its maximum. So it goes top, middle, bottom, middle, back to the top. Okay, again, the reason that I think this is not 3, because I absolutely can see where you think it's 3, is if you did not put these middle in here, you're not going to have the right curvature. You're going to end up with a V-shaped graph, and that's not correct. You got to know where you're aiming for. These are curved, okay, not straight. So make sure you're curving those lines.
Is there an arrow on the end?
Yep. We'll look at a whole graph in just a second. Okay, now what I would like you to do is put your calculator into radian mode. Okay, that's the first thing. Put your calculator into radian mode. And I would like you, don't put everything in there. I just want you to graph. Oh, just a second. Shoot. I want you to graph sine x, but don't do anything yet. Just graph sine x. Pop that into your calculator. Again, you should be in radian mode. Well, yeah. Now, you should be able to, what I would like you to do is go to zoom, and zoom number 7 says zoom trig. Okay, so I want you to do zoom number 7. Okay, so listen, the reason that we do that is because it changes your x-axis to make each of these marks. This is 0. This is pi, though, right here. This first x-intercept is pi, 2 pi, This is pi over 2, 3 pi over 2. So it puts it at the same scaling on the x-axis as ours on our graph that we drew. So zoom trick does that. That's why it looks a little different. So here's my question. What we drew was this much. Oops, did that first one? What we drew was that much. Okay? You can see this graph continues. Okay? My question is why? Okay? Thanks, because it's x. The graph continues. So let me see if I can, I could continue, this guy will go forever. Change your window, it'll go forever. Why?
When you get above 2i, it's basically a coterminal angle with.
Because you can go over, this is formed, you guys, we went around the circle, is what I had you do on Thursdays, go around the circle picking y values, right? How many times can you go around the circle?
A lot.
As many times as you want, right? And every time you go around the circle, it makes the same pattern, Lawson. Every time you go around the circle, it makes the same pattern. So this continues to go infinitely in this direction. Why can you go negative? Because you can have negative angles. What are negative angles?
Negative. Oh, I don't know.
How do we get a negative angle? We talked about this.
Go backwards.
You go backwards, just backwards around the circle. But how many times can you go backwards around the circle? Forever. You can go around infinitely many times. And so this graph continues the same pattern infinitely to the right and to the left. Now, let's talk about its domain then. Okay, what's the domain of sine then? All real numbers. Okay, remember domain is x, range is y. Okay, that's a scribble. Sorry, it's a mistake there. What's the range?
Between 0 and 1. Negative.
Yeah, 1 to negative 1. So you can write that, if you like interval notation, it's the parentheses. If you want inequality notation, it's -1, less than or equal to y, less than or equal to 1. Okay, either of those is fine. I don't care which way you write it. It doesn't matter. Now, we did not graph cosine, but guess what? How many times can you go around the circle? Infinitely many. Forward, backwards, it doesn't matter. So what's the domain of cosine? All real numbers. What's the range of cosine? Same thing, -1 to 1. It's just in a different place. -1 to 1. Okay, now there's a couple things, a couple terms that we need to write down so that we can have some common vocabulary here. Don't put this away, you're gonna need it. So this is 4.5, we're graphing sines and cosines. Okay, so the first thing that we need to talk about is amplitude. First hour, they were like, hey, we talked about this in science. This is a true statement. This section, this is very much a crossover between science class and math class. It's an intersection between the two of them. There's a lot of applications depending on what you go into. There are a lot of applications of this. And I can tell you some of them as we go. Amplitude, though, is the distance from the middle to the top, to the maximum, we'll say the maximum, or the middle to the minimum. I'll draw you a picture in case you don't like my words. I just didn't want to put it on my sine graph. Okay, so this is the amplitude. It's the distance from the center line. That line, I believe, is called, in science class, it's called equilibrium. Okay? So it just levels out. It's the middle. It's the middle. I don't know what else to call it. It's the middle. So from the middle to the top or the middle to the bottom is amplitude. Okay, one or the other, not both. It's not both of them. Okay, that says or, that's what that says there. What's the amplitude of sine? 1. Okay, amplitude of sine is 1. What's the amplitude of cosine?
1.
Also 1. Okay, that's the amplitude. There is another thing called the period of the graph. The period is the amount of time, I'm gonna put that in quotes, it takes for the graph to make one complete cycle. Okay, and I'll show you what I mean, and then we'll write this down because this one's going on the purple sheet. Okay, so just a second. Let me fix this. Oh crap! I screwed something up. Where were you? Oh, I know what I did wrong. That is Miss Rod's class. She's very noisy today.
Oh, you got beef with her today? Yeah.
You dork. Okay.
You're humble, I like that.
Yeah. Yep. Okay. So here is a graph of sine. Okay, this is sine, same graph that you have in your calculator. How much? This is a super logical question if you stop to think about it. Here's where we start. We start at 0. That's the starting point. I don't know if I saw that. And then one complete cycle is through its whole pattern and then back to the beginning where it would then start to repeat another one if you kept going. How much space is that?
4.
Okay,
Hi. 2.
2 pi.
2 pi.
Right?
It's not a graph, right? 2 pi is called, that's called the period of the graph. So the amount of time that it takes to make one complete cycle is 2 pi. Now let me show you cosine. Just a second, I have it. Okay.
Wait, does this mean we get to use this?
No. There's cosine. Okay, here's cosine. It starts here, ends here. What's I had to change the settings myself. What's the period for cosine? Also 2 pi. Okay? Because, you guys, on the graph that we made, we have only one complete cycle of sine and cosine, so that's what we got going on. Their period is 2 pi. Let me go back to my notes. That goes on the number 5 paper.
Isn't it wavelengths and stuff?
What?
Is this like wavelengths and everything?
Mm-hmm. Absolutely.
That's why I assume it's this thing.
Yeah.
Frequency.
Yep. Okay. So the trigonometric period of sine is 2 pi. The period of cosine is also 2 pi. Okay? Now, what I would like you to do is, on your calculator, you can get rid of the sine graph for a second. And go ahead and graph tangent.
Pi. It's pi, isn't it?
I don't know.
I saw some of the during the quiz.
Well, isn't
Tangent of X.
Tangent of x.
This one's real.
Because why would it be like sine over
Like
cosine?
this one's
Which just cancel out.
I wouldn't use that more well.
I think I'm pretty sure.
Okay? It looks a lot funky. So let me say this. As we get into graphing these, sine and cosine, great. Sine and cosine are very normal and they will behave exactly the way we want them to do all of our transformations. Tangent is ugly. Nobody wants to graph that. Take a look at it though, and see if you can figure out what the period of tangent is.
Infinite.
Nope.
What do you want?
Okay, no, I don't want to say that.
3.14.
Is it pi?
Okay, so look at this. Which one? I like that question. So I would say that this, I'm gonna go here because my stuff's in the way over there. Like this is one complete cycle of tangent. So is this one. I just had stuff in the way. Okay.
One.
Great question. One what?
Pi.
1 pi. So the period of tangent is 1 pi. You can write that on your paper. Now, that's a little bit weird. Okay? Because I want you to think about sine, we went once around the circle, so it makes sense that it's 2 pi. Once around the circle is 2 pi. So why is it that tangent is different? And we'll talk about that in just a
2 pi
second.
over 2 pi. That's 1 pi.
No, that's straight up 1. So no. I got where you're going with that, but no. So, couple questions about this. Shoot, I wonder that.
For us?
Yeah. So, what is this here and this here? What's that called?
Starting amplitude.
Range.
Those are vertical asymptotes. Okay? They're vertical asymptotes. We talk about vertical asymptotes because it never touches there. So it will get infinitely, tangent will get infinitely negatively large and infinitely positively large and will never will never be equal to this. So here's the illustration of that. I want you to take your paper, your circle, you need the big circle, and I want you to do the tangent of 90. Okay, I want you to do the tangent of 90 for me, please. Use the circle, the big circle, and find the tangent of 90.
Oh,
Yep. Or the tangent of pi over 2, if you prefer. Okay, Michael. Yes, I finally got around to opening my laptop and trying Dropbox again. And it won't even let me in.
It's a shrink one.
So, okay. So in your message, you said Dropbox will ask me to log in again. And then it should take some time, but it will sync all the things. I cannot even log in. So I can get into the folder, but I can't open anything. They have, I can't see very well, it looks like there's small brown boxes on the bottom left of the like, document icons. Which I have never seen.
I just don't remember it.
Yeah, for sure.
if it's in the morning, I can. If it's before work at 4.
That's the watts.
Wait.
I should text her.
Yeah, probably, which makes sense.
Like we used to all work together.
Yep.
If that worked good, 'cause
202.
someday I might go. I don't know. So I'll text you.
Yeah.
I'll just ask you what time.
No, I tried it, nothing.
It starts out
You
like.
reach your daily limit and your eyes and take that.
Oh, you know what? It's like at 5.
Right.
Yeah, you just go for it. You don't.
Oh my gosh, I don't
Like I have it, it's on, I have it in my list of files over.
because of Netanyahu, that's why you failed your test.
Yes.
Like I'm gonna call.
Netanyahu ordered you to fail your quiz.
I'll text you.
She's like, you're like, Epstein, I'm not there.
Well, I didn't get that. See, now it's showing us.
It's up to you.
Right. Because I could not even get to that, sign-in screen. It looks like it's, yep. That's fine.
The only reason it's gonna look the same
Yep.
and the other guy actually.
Yep, there we go. Well, let's see. Yep, there we go. It opens.
Twice in my whole 2 years have I had this.
Yep. Yeah, I looked in there because that's how it is on my computer at home, so. Yeah. Yep, for sure. I will. Okay, perfect. Thanks so much. Okay, bye. Okay. So what do you get for tangent of 90?
Straight line. Nine. -1.
Undefined.
It's undefined. Tangent of 90 tangent is y over x, and so 90 is 1 over 0. So tangent of 90 is undefined because look what happens.
How come we can graph it?
Because if you're graphing tangent of 90, I don't know.
Oh, what is that?
It's defined. It's
Because you're in radians. If you did tangent of pi over 2, it will not graph for you. Yeah. Same thing if you did negative 90, which is 270. Tangent of 270 is also undefined. It's just negative 1 divided by 0. So every time tangent would be divided by 0, you have an asymptote, a vertical asymptote here. Okay? So tangent works different than the other guys. Let's go back here. So you have to please write this down. So the trigonometric period of tangent is pi. And let me try to tell you why it's pi and not 2 pi. Okay, you do not have to write this down, but if you take a look at the quadrants here, we've got a positive tangent and a negative tangent. We've got a positive tangent and a negative tangent. If we go all the way around, let's see if I can zoom out. These, if you were to calculate all of the tangents, this guy, let's see, this guy would be positive 1/2 over square root of 3 over 2. This guy would be negative 1/2 over the square root of 3 over 2. Okay, we're not going to simplify that. This guy would be positive 1/2 over the square root of 3 over 2 negative. So this is positive tangent with the same coordinate points, except these are negative and these are positive. So because of the positive and negativeness of what we've got going on here, this repeats itself twice around the circle. So tangent, whatever the tangents are on the top half are exactly the same as the tangents on the bottom half. And so what's happening is if you go twice or once around, you get 2 separate cycles of tangent in there. Okay? Do you have to worry about that? No, you don't, but that's why it does that. Now, what we're working on are transformations. Okay. Well, actually, let me have you graph cotangent. We're not going to be graphing cotangent. He's ugly. Nobody wants to graph that. So you graph cotangent, and I'll keep tangent up there so that you can compare. 1 divided by tangent. Great question. 1 divided by tangent.
No, you can just do different.
You can do division or you can use the fraction. Yep.
Whoa. Ooh, it's backwards.
This and what else? It's moved this way, like it's upside down. Like this tangent goes always up. Cotangent always goes down. Also, I think if you look at cotangent, isn't it like, it looks like this. It's not going to be beautiful, but like, does it look like that? So it's not, it's vertical asymptotes are at 0 and pi instead of the pi over 2's. Okay, so it's shifted a little bit, right, left, however you want to do it, and it's upside down. Nobody wants to graph these. We're not graphing them, but what's this period? Pi. Period is pi, which is not super important, but we got to have a complete paper, so we'll go with that. Okay, so the period of cotangent is pi.
That means secant, cosecant,
So let me ask you this question. Isn't cosecant 1 over sine? Right? So doesn't it make sense that they'd be related to sine? Makes sense. We're not talking about them today, though. Okay, so we talked about transformations a lot in first semester. We're going to hit them again and a little bit differently because we're actually going to be graphing these. So first thing I want you to do is take a look at this. Okay, it looks like some gibberish, but there are 4 potential numbers that we could put in there. I could put in A, which we'll talk about that in a minute, B, C, and D. Okay, A, B, C, and D. This trig right here could be anything. It could be sine, cosine, secant, cosecant. It could be tangent, cotangent, but no, we'll just go with it. It could be, but we're not going to do those. So this could be sine, cosine, secant, cosecant. And we will, by the time we're done, know how to graph sine, cosine, secant, cosecant with potentially all 4 of these transformations. Okay, and graph by hand, not with our calculator, just in case you thought. Okay, so what I would like you to do is in your calculator, you don't even need to write this on your paper, but I want you to see it. I want you to graph y equals 3 sine x along with y equals regular sine x. Okay, so graphing both of those. 3 sine x and sine x. You can get rid of the cotangent graph.
At the same time.
Yep.
It's like a vertical stretch.
It's like
Horizontal stretch.
it's like a reaction to the catalyst.
I think it's like
That's so
weird. Look at the red. Calculating myself something like
Okay, so I'm going to zoom out a little bit.
that.
It's like a chemical reaction to the catalyst.
So there's a couple.
Josiah does.
We're not playing chemistry today. Sorry. So what I would like to know, just a second, let me change the scale on my graph because I don't like that. Y-axis, I would like that to be 1. Okay, better. Okay, now, what do you notice that's similar?
They meet at pi.
Okay, why?
Same zero.
Because it has the same x-intercepts or zeros, right?
They both go up.
They do, which we would hope because it's the same shape, right? So they're both sine.
You both have the same period.
They both have the same period. Okay. What else? What's different?
Different colors.
Different wires.
Thanks.
One is longer.
Carson?
One's 2 times bigger than
The other one's 3 times bigger. Okay. Specifically, you can see that best at the maximum. What's the maximum of regular sine? Regular sine. 1. What's the maximum of 3 sine? Go figure, right? Go figure. His maximum is 3 sine. thinking about the words that I already taught you, it changes the amplitude. Okay, so that A, the first thing we want to write down. Ezra, did you have a question or a notice? Okay, so this is A, and A changes the amplitude. Okay, now I think it was Jack said vertical stretch. This is a vertical stretch. This is what it would look like. It was braided. Copyright braided. But because we're using words that overlap with science, we will say that this is a change in amplitude. Okay? The nice thing about that is if it's a shrink or a stretch, it's still changing the amplitude, so it does not matter. Question?
What's the amplitude of tangent?
The tangent does not have an amplitude, which is one reason we're not going to graph them. Now, 2 tips for you. You always read this as a positive number. Okay, we will talk about what happens if that A is negative, but it does not change the amplitude. And amplitude is never a negative number. Amplitude is a distance, and so distance is always positive. Okay, the other thing that you need to know is that the definition of amplitude is maximum minus the minimum divided by 2. Okay, the parentheses are super important on that. Make sure you have them. Maximum minus the minimum divided by 2. Because we're going to go the other way too.
Wouldn't that be 0 though?
Okay, so let's go with the 3 and the negative 3. Maximum is 3. What's the minimum?
Oh, yeah, so it's a plus 3.
Divided by 2.
Okay.
Does that make sense? That's what. Okay. Go ahead and put your stuff away, and you can put your calculators back. We will pick up right there tomorrow.